Hi everyone, Dex here with TGW, and welcome back to another Whiteboard Session. If you've listened to our podcast, you've probably heard us talk about mobile robotics and the impact they have on warehousing and production environments. Today, I want to zoom in on a specific and very powerful segment of mobile robotics, goods-to-person systems, or GTP. You're probably wondering, why goods-to-person? And let's dive into it. Alright, so if we begin to look at a traditional warehouse environment, you have a bunch of pallet racking. And underneath, you might have some sort of other shelving or different types of picking where you have, your different shelves to pick from. Up above, you might have, big boxes for bulk storage on pallets. All right, so here you have your pallet racking, you have areas for people to pick on, and then here you have your aisleway. Now in the aisleway, you might have a few different ways of picking these goods. So for one, you might have a forklift truck that's going and they're picking the pallets, they're bringing them down. This could be to pick off of, or it could be for replenishment. The other type of thing we typically see is you may have a person walking around and they could be using a pallet jack and picking to a pallet, or maybe they're pushing a cart around and the cart has, several areas for different orders. And so they're picking a few orders at a time. They're going to the shelf, they're grabbing the items they need, and they're placing it into the cart. The huge challenge with this is it uses a big waste of time of people walking. So pickers can easily walk miles a day just walking to collect the items that they need. In goods-to-person systems, we flip that model. Instead of people walking to the product comes to the person. The result? Faster picking, higher throughput, and less physical strain on workers, not to mention more consistent performance. So let's start with LivePick, our mobile robotic climbing solution. So this is going to show a little bit of an angled view here, just to provide some more context. So take this somewhat poorly drawn 3D model here, and basically you have totes that are stored in these areas, and you have a climbing mobile robot that attaches to these rails here, and this mobile robot basically climbs up and it grabs the totes out of the system and it can use it for storage and retrieval. And then there's this space underneath here where this arrow is pointing. And what this space is used for is driving underneath. So if you picture having a bunch of aisles of this, so this is kind of like a side view of it, but looking at it from a top view, you may have aisles here. And so these aisles are where the mobile robots are going. They're kind of underneath them. And this way they're not disrupting traffic too much, but they're going up and down the aisle. And then they're climbing these rails here, grabbing what they need, and they're bringing them out. Looking at it from a different perspective, you may have this area, which we'll say is a block, a big cube full of these climbing mobile robots where everything's being stored and retrieved. And then in this area, you may have a carton producing machine. Here you have pick stations or workstations. And then here you might have like a carton litter, for example, or a carton closer. And then over in this area, you might have your shipping lanes that you're preparing. And here's where you have the trucks being loaded outbound. So within this little grid system here, you have mobile robots going back and forth, climbing up these rails and totes. So maybe on this one, we'll use it as an inbound system, for example. So you have a person with a pallet full of stacked boxes. What they're doing is they have a mobile robot coming. One's maybe waiting right here, one's at the pick station, and one's on its way out to go back into storage. So that way you have a constant material flow coming in. And you have a person here that's basically taking goods off of this pallet and they're loading them onto a mobile robot at this workstation, and the mobile robot's bringing it into this grid for storage. Now on these other areas, let's say it's more for picking and more for outbound. And so you have your workstation here, and in this scenario, you have a mobile robot that maybe was climbing up here, it grabbed the tote it needed, and it's bringing it to this workstation. It's waiting in line here while there's one already in place. And so the worker is basically picking the goods, and then they're placing it into these outbound squares here. So maybe they're doing what we would call like a 1 to 4 workstation. So they have 4 outbound orders at the workstation and one person that's picking the goods from the system and putting it into, let's say, these little squares are mobile robots with cartons that were pre-erected over here. And so they're picking into the order carton. Once the order carton's complete, it will move into the litter machine, again, via mobile robot. And then from there, it can be staged into the outbound area. So again, on the inbound process, goods are decanted into trays or totes at the inbound station. Mobile robotics climb the racking structure to store the totes. When an order is released, the robot retrieves the required tote, and then the tote is delivered directly to the picking workstation. The goods are picked onto a carton, taken away by mobile robots to a carton litter or carton closing machine where things get labeled, and then it goes into outbound. So, what makes the LivePick system work so well? It's that you have mobile robots climbing this system here. This approach delivers extremely high storage density, easy scalability. Simply add robots, racking, or workstations as demand grows. You have much higher picking rates compared to person-to-goods models, and a safer, more ergonomic environment for your workers. All right, so now we talked about LivePick and a robot climbing system. We'll talk about a different type of goods-to-person system with mobile robotics. We'll call it our shelf-to-person. This can be good at handling bulky or awkward items. So let's talk about it. In a shelf-to-person environment, you may have these big shelves here. And underneath, this is where you have your mobile robots. They're basically lifting the shelf to move it to the person. Now, the shelves can be configured in a variety of different ways. So you may have, a long section with some like cross straps or something like that here. And so those could be good at holding like really long, weird shaped items like, let's say these are skis, something typically difficult to store. Or you might have a sofa or something else that's pretty large and often difficult to handle. And then on this side, you may have a bunch of other shelves that hold a bunch of different items. So you may have complementary things like a box full of gloves, let's say your sporting goods, or you might have some spare parts for furniture or add-on or other little smaller pieces of decor that are all stored in this shelf. That's kind of a side view of it, but when we look at the overall view, we'll have this big area here. And this is a fenced off area. And then we're gonna have little openings here. These will be our workstations. And then we'll have this little area over here, and that will be for maintenance. So you have your maintenance area here, you have your 3 workstations here, and we'll have this area, we'll have a little lightning bolt like thing. This is our opportunity charging area that we'll talk about in just a moment. So at the workstations, we'll use this example again for inbound. So you may have a pallet full of things that you need to put onto one of these shelves. Outbound, you might also have a pallet that you're picking to, or maybe you have a mobile robot here as well, and it's bringing goods to outbound. So we'll start with the inbound process. You have a pallet and you need to decant it into here, into one of these shelves. Okay, we'll start by talking about how the layout works. So imagine this is a top view. Each little square here is a shelf sitting there. Underneath it, you have mobile robots that can go in and out. And basically, you have a person that's trying to put into these systems, into these shelves at the inbound station. So you may have one mobile robot waiting, you may have one being loaded, and then you have one over here that's trying to go back into storage. So at this inbound station, you'll have a person and they'll have basically a put to light, directing them saying, hey, put item A on this shelf. And the idea is that people putting items into these shelves can be much more efficient. Again, think about going to manual racking where you're dragging up and pallets up and down the warehouse trying to put these things away. Instead, you're putting it into a shelf to be ready and easily grabbed when the time asks for it. Similarly, you may have something on the order picking side. So here you have a shelf full of items being ready to go into being picked, and you have one where you're actively picking into. Similarly, you may have a light again shining on which shelf you need to pick an item from, and then you put it back here on this pallet or back here onto this mobile robot. So this we'll use as the aisle to carry the shelf. So again, you'll have more aisles here and here and here and here. And basically you have a bunch of aisles in between. And the idea here is you're getting a lot of storage density. This person's picking the goods they need, putting it on the pallet. This next robot's bringing it back to where it needs to go. The idea is by having multiple mobile robots, you're constantly feeding the station. So as soon as this one's picked to, it moves into this area and then gets put away. And as soon as this one comes, it goes to be picked into, and another shelf comes out of the inventory waiting to come here. So here you get a lot quicker pick rates than a person to goods system. And so if you can imagine in the square footage, you have a lot of storage density. These shelves are leaving only enough room to go up and down the aisles, and then the mobile robots are driving underneath. One of the best benefits to having this set up the way it is you can have what we call in-process charging. As long as a mobile robot's sitting for, let's say, 30 seconds, think of it like an inductive charger. So you have this book here. Let's say it's the charger and this is the mobile robot. By simply sitting above it for a little bit, it's getting a charge. And that charge is going, and you have a few of them here. So you're getting, let's say if the pick is taking 30 seconds, you're getting about a minute and a half between these three spots where you're charging. This continuous charge allows you to have fewer robots in the system, helping reduce costs. And then sometimes when the battery gets too low, you still may need to take opportunity charging, and that's when you'll have a robot go over to this area and charge until it's needed. So our simulations will help find the best way to get as much storage density as you can and have the best appropriate number of robots and the right charging strategy to make sure you can be as efficient as possible. Then you have this area over here where you have your maintenance area, and these items, like any automation, need to be serviced. So this allows you to service this without disrupting operations. So let's touch back at this workstation for a moment. We have this fenced off area over here. So why is this area fenced off? It allows the mobile robots to travel at a higher speed, making you more efficient. And you have these little pick windows where it's opened, and you might have a light barrier sensor, so that way if somebody crosses the barrier, the system shuts down for safety. So it's not just a fast and effective environment, it's a safe one. And then you can add additional technologies such as sensors to the mobile robots where you can actually have a person walk inside this space, and within a certain amount of meters from the person, the systems move at a slower pace, meaning you don't have to shut down operations at all, and you can go troubleshoot or check items into inventory, whatever you need to do there. Also at these stations, these shelves can be kind of high, so what you might have is like a little ladder system to help you pick goods or put away goods to handle various heights, and it's being taken via forklift or mobile robot to your outbound processes for labeling. So if you think about, walking up and down aisles, you're saving a lot of time here. So this type of picking is ideal for weird shaped items. Think of like skis, golf clubs, furniture, decor. With these shelves, you can also have apparel on hangers or any kind of long, awkward products. These shelves can be customized in size and configuration. You can have vertical slots here like you do for skis. You can have the hanging rails. You can have cubbies to put in boxes or different decor. You can have mixed formats in the same system, and that flexibility is a huge advantage. And the robot moves the entire shelf to the operator, who then picks or places onto them. Then you have an outbound pallet, conveyor, or shipping cart. The secret sauce behind this technology is our software suite, WERX, which handles the management of the mobile robots. It ties the systems together to handle slotting, picking, and put away to make the workforce more efficient. Now you have this system. And one of the unique aspects is with the shelves, you can maybe only go, let's say 6 to 8 feet high, because people need to be able to pick this. You have a lot of vertical space in your warehouse. How do you maximize it? So with this, you can also build a mezzanine. So if you think about each level, you have Here, a bunch of different robots in that shelf to person configuration. Over here you have your pick stations. And you may have what we call mobile robotic elevators. And these elevators are these designated zones where they'll go down over here. And this way you're getting a huge storage density with these. So with a lot of fixed automation, you may have like a shuttle system or some mini load ASRS that's, providing vertical dense storage. With mobile robots, it can be a little bit trickier. And so that's where having our LivePick could work. But if you're dealing with bulky items or weird shapes or maybe slower moving items that you need to store in a cost-effective manner, this is where the system can come into play with the elevators. What you get is a dynamic, scalable, and flexible environment. With mobile robots, you can anticipate cost-effective solutions meant for easy scalability. One that can handle a wide variety of goods, increase throughput, and significantly reduce unnecessary movements in the warehouse. And with TGW simulation expertise, we can design the right mix of workstations, storage locations, and robots. These mobile robotic-based systems are great for greenfield and brownfield sites and can help bridge the gap between low and high throughput. As we support our customers, once you hit very high throughput, we often lean towards a fixed, quicker throughput solution, such as a shuttle-based goods-to-person system. As a leading systems integrator at TGW, we help design end-to-end solutions. We put our customers first and create solutions with the right blend of technologies for their business. Curious on which technologies best suit your needs? Reach out and chat with our team today. Thanks for joining this whiteboard session, and I'll see you on the next one.